Okay, imagine for a second. Not just that everything you know is wrong, but that everything you think is real isn't.
Uh-huh.
What if your body is an illusion? What if the stars above you are just, like, pixels?
Right.
What if the entire sprawling history you remember is just a glitch? A glitch in some cosmic machine that, statistically, might actually prefer to create a lonely, disembodied mind with fake memories over a whole universe like ours.
It's a wild thought, yeah.
Pretty wild, right?
Mhm.
Almost like something out of a movie. But maybe it's closer to home than you think. Welcome to the cool, weird, and possible.
Yeah.
And yes, today we are diving headfirst into some truly mind-bending ideas.
Mhm.
Ideas that challenge everything you thought you knew about reality, the universe, and, well, maybe even yourself.
We definitely are. Today's deep dive is titled Crazy Theories About the Universe,
Yeah.
Unifying Cosmological Theories and Paradoxes. And you've given us quite a stack of material here. We've got articles, research, looking into concepts like Boltzmann brains, the simulation hypothesis, the cyclic theory of the universe, different multiverse ideas like bubble universes and shadow matter,
Wow.
and even a look at, let's say, alternative theories like the electric universe. Plus, we have to touch on the implications of the Great Filter. That sort of chilling question, where is everybody?
Okay, my brain is already buzzing just hearing that list. It sounds less like cosmology and more like, I don't know, theoretical philosophy had a baby with a sci-fi horror movie.
Chuckles lightly. That's not a bad description for some of this.
So what's our mission today? With this particular stack of sources, what are we trying to pull out of it?
Well, the mission is really to extract the most intriguing insights and, maybe more importantly, the paradoxes from all this material.
Okay.
We want to explore some of the wildest ideas floating around in cosmology and physics right now. The ones that make you stop and think, wait, is that even possible? We're looking for the core takeaways, the distilled essence of why these concepts are so fascinating, maybe even unsettling, and what they might tell us about the nature of reality. Or at least what we think is reality.
All right, buckle up then. Let's
Yeah.
unpack this. Starting with something that sounds utterly bizarre. Boltzmann brains. I mean, just the name itself.
Yeah,
It conjures up images of, like, a disembodied mind floating in space.
it does.
What is this concept, and why are scientists even thinking about it?
Well, what's fascinating here is that the Boltzmann brain isn't just some sci-fi invention. It's actually a thought experiment.
Okay.
It comes directly from applying thermodynamics, specifically the theory of entropy and probability to the universe itself, especially within certain cosmological models.
Right.
The basic idea is, well, given enough time, potentially infinite time in some models, even the most improbable states could eventually arise just from random thermal or quantum fluctuations in a vacuum, or maybe a state of really high entropy.
Fluctuations creating what exactly?
The concept suggests a conscious entity, essentially. A brain could theoretically just fluctuate into existence spontaneously, purely from random chance.
Without a body, without a planet.
Exactly. No body, no planet, no surrounding universe needed, just the conscious entity itself.
Wait, a brain just popping into existence out of nothing? How? Why?
Yeah.
That completely defies common sense.
Yeah.
My brain is hurting just thinking about it.
It absolutely seems counterintuitive to our everyday experience. I get that. But the concept originates when you look at the vast timescales involved in cosmology
Immense timescales, right?
and the nature of thermodynamic equilibrium. So if the universe were to eventually reach a state of maximum entropy, basically, a featureless uniform soup, right? Thermal equilibrium.
Okay. The heat death of the universe kind of thing.
Sort of, yeah. Over potentially infinite time in that state, then any structure that's not in equilibrium, including something as complex as a conscious brain, would statistically have to appear eventually as just a random temporary fluctuation away from that state.
But are we talking ridiculously small probabilities?
Yeah.
Like smaller than winning the lottery every second for 1 billion years while also being struck by lightning? Kind of small.
Vanishingly small, yes. But the source material actually gives us some numbers here, which helps make it a bit more concrete, even if the numbers are, well, astronomical.
Okay, let me guess. Really, really small.
Really small. It approximates the probability for, say, a 1 kilogram Boltzmann brain forming via nucleation in what's called de Sitter space. That's a common model for our universe's expansion at 10 to the power of negative 1069.
Dinus. 1069. Okay, that's
Yeah.
Meaningless, almost.
Pretty much. For a thermal fluctuation, it's slightly better, around 10 to the minus 1066. Even in just empty space, Minkowski vacuum, it's maybe 10 to the minus 1050.
Still incomprehensibly tiny numbers.
Absolutely. And I mean, people talk about the estimated lifetime of the universe maybe going up to 10 to the 1050 gig years. These probabilities are just staggering, far beyond Google's or Googleplex's.
Okay, those numbers are so small they don't even compute. My brain refuses to process them, pun intended. But the source also says something else, something that sounds truly weird.
Uh-huh.
It says a Boltzmann brain, spontaneously fluctuating into existence within our current universe, has a tangible, quantifiable, and more than cosmological probability. What does that mean? Is it saying a disembodied brain is more likely than our universe existing as we see it? Because that sounds like the ultimate cosmic joke.
And that is precisely where this goes from being just a weird theoretical curiosity to a really profound cosmological paradox. It's a key insight from the sources.
Okay, explain.
In some cosmological models, particularly ones involving eternal inflation, where the universe keeps expanding forever, or just vast empty spaces where these random fluctuations can happen over immense timescales.
Right.
The statistical calculation actually suggests it might be more likely, statistically speaking, for a random fluctuation to create just a single conscious entity, a Boltzmann brain, that has false memories of a complex universe like ours. Then for the entire complex universe, with all its stars, galaxies, planets, and observers like us, to exist naturally through the standard processes we think we understand.
So in some theoretical scenarios, a lone, disembodied brain hallucinating everything as move. The sky, the ground, its own past, is statistically more probable than the universe we observe actually being real.
That's the paradox.
Yes.
It is.
Deeply, fundamentally unsettling. It feels like reality is playing some kind of trick on us.
It is a deeply unsettling idea, and the source material adds another layer. It points out that even if these Boltzmann brains did form cosmologically, they might be cognitively unstable.
Unstable how?
Like, they might not even be able to pass a Turing test. They could potentially exist fleetingly in forward or backward time, basically making them effectively unthinking blips, unobservable, unconfirmable glitches in the cosmic fabric.
Which then completely ties back to that opening thought, doesn't it? What if our memories aren't real? What if we were just one of these fleeting, unstable fluctuations, experiencing a temporary but very convincing hallucination of a vast, complex universe? My head feels like it's about to fluctuate right out of existence just considering it.
It's a profound philosophical challenge posed by the physics, absolutely. It forces you to question the reliability of your own perceptions, your memories. And that provides a really fascinating link to another concept that plays with the very nature of reality.
Let me guess. The simulation hypothesis.
You got it. The simulation hypothesis.
Ah, yes, the ultimate sci-fi trope, right? The idea that we're all just characters in some cosmic video game or a massive computer program.
Essentially, yeah. Though maybe a bit more sophisticated than just a video game. The hypothesis posits that what we experience as reality is actually a very, very advanced computer simulation.
And there's an argument for this, like a logical one.
There is. Philosopher Nick Bostrom laid out what's called the simulation argument. It's a trilemma, meaning there are three possibilities, and logically, one of them must be true.
Okay, what are the three?
He argues that either 1, advanced civilizations capable of creating highly realistic conscious simulations almost always go extinct before they reach that technological stage.
Okay, extinction. Fine.
Possible. 2, if they do reach that stage, they universally choose not to run such simulations. Maybe for ethical reasons, perhaps it's forbidden.
Right, maybe it's seen as immoral.
Or 3, and this is the chilling one, if they do reach that stage and they do run these simulations, then the number of simulated realities would vastly, vastly exceed the single base reality.
Ah.
So in that third scenario, if you are a randomly chosen conscious entity, you are almost certainly living in one of the simulations.
Because there are just so many more simulated minds than real ones.
Statistically, yes. This argument hinges on the idea that consciousness isn't necessarily tied to biology, but could arise from complex enough computational structures.
Okay, so the insight here is the statistical argument. Given enough advanced civilizations that can simulate, it's more likely we're simulated than base reality. But hang on. Why would they necessarily run ancestor simulations, which Bostrom focuses on?
Good question.
Maybe they'd simulate fantasy worlds or something totally different. And like one of the sources suggests, maybe creating conscious beings inside a simulation is considered profoundly immoral in the future. Like keeping them in a cosmic zoo or something.
That's a very valid point, and it's raised in the sources. It presents potential reasons why the second possibility in Bostrom's trilemma, that advanced civilizations choose not to run simulations, might actually be the true one.
Are there other criticisms?
Yes, the sources mention others. One point is that it feels a bit like a variation of the old cosmological argument, what came before that, ad infinitum.
Right. If we're in a simulation, who simulated the simulators?
Yeah, no,
Who simulated them? Turtles all the way down.
exactly. It can create what one source calls an unnecessarily cluttered worldview with this potentially infinite nesting of realities. And it doesn't really solve the origin problem. It just kind of shifts it up a level.
So it doesn't explain the ultimate beginning, it just adds more layers?
Pretty much.
Yeah.
From a physics perspective, the sources mention that the idea that the universe operates according to a finite set of rules does mean it could, in principle, be simulated.
Like the universe itself is a computer.
Well, some sources mention the idea of the universe as a quantum computer itself, which is actually different from thinking of it as a simulation running on a separate system. But a major criticism highlighted across the board is just the complete lack of empirical evidence.
No glitches in the matrix.
Not that we can detect. There's no observable sign of, digitization or some underlying grid structure at the most fundamental level, the kind of thing you might expect. And crucially, advocates haven't really offered experimentally testable predictions that could distinguish our reality from a simulation.
Okay, so maybe we're not just brains popping into existence, nor are we lines of code. Let's shift gears completely then. Let's look at some alternative, maybe radical ideas about the structure and history of the universe itself. I saw this electric universe theory mentioned in the Reddit source. Sounds like a real underground theory, right? Yeah. Totally throws out standard models based on gravity.
It certainly is presented that way, yes. The electric universe theory, or EU, as described in the sources, basically proposes that electromagnetic forces, especially those involving plasma, which is, the most common state of matter in the universe, are way more significant in shaping cosmic structures and phenomena than gravity is.
Which is the opposite of the standard model, where gravity rules the large scales.
Exactly. Gravity is dominant in the standard cosmological model for large structures.
So what are the core claims of EU? Like, they say the sun isn't even a nuclear furnace, right?
Yeah.
That is powered by cosmic electricity.
That's correct. That's presented as a key claim.
Flowing through space. And that this plasma, this electricity, explains things like why the sun's corona is so incredibly hot.
Yeah.
Millions of degrees hotter than the surface.
Yes, according to the sources discussing the EU model, proponents claim the sun is powered externally by galactic electrical currents, flowing through plasma filaments in space, kind of like a giant electrical discharge. They argue this external electrical heating explains the hot corona, and that sunspots are actually deep, cool holes where this current flows in. They also use electrical explanations for things like comets suddenly flaring up near the sun.
Okay, but what does mainstream science say about those specific things? Because the Reddit source we looked at has some, shall we say, very strong opinions about the EU theory. It wasn't holding back.
No, it wasn't. That source provides a clear counterargument based on standard physics, which, it emphasizes, is verified by tons of observation and experiment.
Right.
It states the sun's corona is heated by really complex processes involving magnetic fields. These fields are generated by the intense churning convection of plasma inside the sun itself.
Not external electricity.
No. These internal magnetic fields interact through things like magnetic induction, wave action, reconnection events, transferring huge amounts of energy up into the corona.
And sunspots.
Sunspots are cooler than the surrounding surface, that part's true, but standard physics explains them as cool depressions where extremely strong magnetic fields pop out and actually inhibit the upward flow of heat from below via convection.
Okay. And the comets?
Comets reacting violently near the sun. That's explained by sublimation, basically. Ice turning directly into gas and ionization, atoms losing electrons, both caused by the intense solar wind and UV radiation from the sun. These are processes totally consistent with standard physics, no need for external electric currents.
And the Reddit source was pretty critical of the EU theory overall, wasn't it?
Yeah.
Uses phrases like, not even wrong. That sounds pretty damning in science.
It is. That's indeed the core critique presented in that source. It argues EU is not even wrong because, in its view, it isn't actually a coherent, testable scientific theory in the first place.
Why not?
Because real science requires making quantitative predictions. Predictions you can go out and test experimentally to see if they're right or wrong. The source argues the EU model just doesn't do that. It lacks these falsifiable predictions.
And it pointed to evidence contradicting EU.
Yes, it mentions overwhelming evidence for solar fusion, like the continuous detection of neutrinos coming directly from the sun's core, which directly contradicts the E claim that the sun isn't a nuclear furnace.
Okay.
It also notes, and this is commentary from the source, that EU proponents sometimes respond to challenges with invective or by ignoring conflicting data. It even compares the theory's structure to older debunked ideas, like the luminiferous ether.
Which was that invisible medium they thought light traveled through, right?
Yeah.
Just proven by experiment.
Exactly, like the Michelson-Morley experiment.
But what if mainstream science is wrong sometimes? What about the claim, also mentioned in that source, that the electric universe theory is being maliciously suppressed by the scientific establishment? You hear that kind of thing in other contexts, too.
Right, and the source you're referencing does mention that claim of malicious suppression, but it's careful to frame it as one of the characteristics often associated with pseudoscience itself, rather than presenting it as a confirmed fact about this specific theory.
Ah, okay. So the source isn't saying it is suppressed, but that claiming suppression is a common tactic in pseudoscience.
That's how the source presents it, yes.
Yeah.
It strongly argues that real science is characterized by being self-correcting and provisional. Theories get challenged, they get tested rigorously, and they're either modified or thrown out based on empirical evidence and those testable predictions. The source argues that the EU theory, as presented by its proponents, lacks these fundamental aspects of the scientific method. And that's why it remains outside the mainstream consensus, according to that source, not because of some conspiracy to suppress it. It's about the methodology and the evidence, or lack thereof.
Okay, fair enough. We're reporting what the sources say, and that particular source presents a very critical view based on the standards of the scientific method. Okay, moving on from potentially disembodied brains and maybe non-electrical universes, let's look at other alternative but perhaps more mainstream adjacent models for the history and fate of the entire cosmos, like the cyclic theory.
Right, the cyclic theory. This is a fascinating and pretty radical alternative to the standard Big Bang plus inflation model that most cosmologists work with.
How does it work?
Mm-hmm.
I know an early version involved something called M-theory, brains.
Exactly. An early version was based on M-theory, which is a framework within string theory. It proposed our universe exists on a three-dimensional membrane, or brain,
Okay.
separated by a tiny gap from another brain, existing in an extra hidden dimension of space.
I love the image included in the sources. It really helped visualize this. It looks like two gray, kind of wrinkled sheets representing the brains, drawing closer together.
That's a perfect description of the diagram and the core idea. These two brains pull towards each other through that extra dimension. As they get close, tiny quantum wrinkles on the brains get amplified. Then they collide.
And the collision is?
The collision is the Big Bang in this model. It creates incredible hot plasma, that's our universe, starting its expansion. Then the brains rebound, they bounce off each other.
Okay.
As they move apart and stretch, that corresponds to our universe expanding. Eventually, dark energy takes over, driving accelerated expansion, just like we observe. But then, eventually, the brains start contracting back towards each other again.
Leading to another collision.
Exactly. Leading to another collision, another bang, initiating an endless cycle. Crunch, bounce, expand, contract, crunch, bounce.
So it's like a cosmic accordion, breathing in and out forever.
Yeah.
That avoids the whole beginning of time problem of the standard Big Bang.
In essence, yes. It potentially offers a universe without a true singular beginning. Though the source does note the cycle isn't perfectly periodic in terms of the overall size of the brains because they stretch over time, but key local observables like the temperature and density right after each bounce do return to very similar states.
And there are newer versions without the extra dimensions and brains.
Yes, the sources mention more recent formulations. These use more standard quantum field theory just in our familiar four dimensions, three space, one time, without needing the brains or extra dimensions, but they manage to mimic the key features of that colliding brain picture.
What's the main advantage or innovation here compared to the standard Big Bang plus inflation model? How does it explain things like why the universe looks so flat and smooth on large scales? Inflation handles that in the standard model, right?
Right. Inflation explains smoothness and flatness by proposing a period of incredibly rapid exponential expansion right after the Big Bang, stretching everything out super fast. The key innovation in the cyclic model is something different, called the ekpyrotic phase.
Ekpyrotic. Okay, what's that?
It refers to a period of ultra-slow contraction that happens before the collision or rebound moment.
Ah, contraction before the bang.
Exactly. And the source emphasizes that this ekpyrotic phase, this slow squeezing, is what's responsible for explaining the universe's observed smoothness, its flatness, and also for generating the tiny initial seeds for large-scale structure, like galaxies.
How does slow contraction do that?
The idea is that the slow contraction gives different regions of the universe enough time to interact and smooth out any density variations before the bounce happens. It's a fundamentally different mechanism for setting those initial conditions compared to inflation, which smooths things out by expanding regions so incredibly fast they become causally disconnected.
So instead of smoothing by expanding faster than light right at the start, like inflation says,
Yeah.
the cyclic model smooths by contracting really, really slowly beforehand. That's a cool contrast.
Yeah. It is a neat conceptual difference, precisely. This approach might also offer a new way to think about the cosmological constant problem, the puzzle of why dark energy, the stuff accelerating expansion, has the incredibly tiny value it does.
How so?
Well, the source suggests that in a cyclic model, the value of the cosmological constant might be able to naturally relax, very slowly, over many, many cycles, getting smaller each time, perhaps. That's something that's quite difficult to arrange naturally in most standard inflationary models.
What about the bounce itself, though? Can you really go from a big crunch where everything collapses down, maybe to a singularity, to a big bang, where it explodes outward again? Doesn't physics break down into singularity?
That's absolutely one of the major theoretical hurdles, yes.
Yeah.
And the source discusses ongoing theoretical investigations exploring how a non-singular bounce might actually be possible.
Avoiding the singularity altogether.
That's the goal. Ideas involve some pretty complex theoretical concepts, like using hypothetical energy fields called ghost condensates, or applying techniques from string theory like the ADEX-CFT correspondence, which relates theories of gravity to quantum field theories. These suggest there might be mechanisms where the big crunch big bang singularity could potentially be replaced by a smooth, continuous rebound.
Wow.
The source also mentions another interesting possibility. Maybe mini black holes form during the crunch phase, and then they evaporate via Hawking radiation after the bounce. That could potentially explain the observed entropy, the arrow of time, in our universe without needing a true singular beginning. But these are definitely still areas of active, highly theoretical physics research.
Okay, so from infinite cycles and potentially smooth bounces avoiding singularities. Let's zoom out even further. Let's think about the possibility not just of different models for our universe, but the possibility of other universes existing entirely. Multiverse theories.
Right. The sources touch on a couple of different multiverse concepts. One that comes up fairly naturally in some models of inflation is the idea of bubble universes.
Bubble universes. Like cosmic soap bubbles.
Sort of. If cosmic inflation, that rapid expansion early on, is actually the natural sort of default enduring state of space-time,
Okay.
then regions where inflation randomly stops could nucleate out of that inflating background. They'd form separate bubbles of normal space, like the universe we live in.
And this would keep happening.
Potentially, yes. In an eternally inflating background space-time, these bubbles would constantly be forming, creating countless such universes separated by vast, ever-expanding distances, essentially a multiverse of pocket universes.
In these bubbles, could they have totally different laws of physics inside them? So maybe in another bubble universe, gravity works differently or the speed of light is different.
That's the really mind-bending part, yes. According to the source material discussing this, the precise way that the high-energy inflationary state cools down or transitions into the lower energy state of a normal universe inside a bubble, well, that transition could potentially lead to different fundamental constants, like different particle masses, different strengths of forces, maybe even entirely different sets of fundamental forces or particles in different bubbles. So yeah, you could potentially have universes with entirely alien physics, completely unlike our own.
That's both incredibly cool and,
Yeah,
a bit unsettling. Whole universes we can't even see or interact with, potentially running on entirely different operating systems. It really makes you feel very small, doesn't it?
it certainly pushes the boundaries of what we can currently observe or even test scientifically. Another related idea mentioned in the sources is something called shadow matter or mirror matter.
Shadow matter. What's that?
This hypothesis posits the existence of extra generations or sectors of particles beyond the ones we know in the standard model. Essentially, copies of our own electrons, quarks, protons, neutrons, photons.
Copies.
Yes, but copies that only interact significantly with themselves through their own set of forces. They wouldn't interact with our particles through electromagnetism or the nuclear forces, possibly only interacting with our sector through gravity.
So, Like a parallel universe made of the same basic building blocks, maybe. But completely invisible to us because it doesn't interact with our light or our forces, except maybe gravity.
Exactly. It would be a form of matter potentially forming entire structures that would be undetectable by us through normal means. You could potentially have entire shadow galaxies, shadow stars, maybe even shadow planets, and shadow life existing right alongside our own.
In the same physical space.
In the same physical space, yes. But we'd never see them directly. Think of two completely independent sets of cosmic structures occupying the same volume, only very loosely coupled, maybe just through their combined gravitational pull.
Okay, Boltzmann brains, simulations, bouncing universes, bubble multiverses, shadow matter. This is quite the cosmic mind-bender tour we're on. And all of this vastness, all these possibilities, it brings us inevitably to one of the biggest, most enduring paradoxes in cosmology and the search for life. The Fermi paradox.
Right.
If the universe is so incredibly vast, with potentially billions or trillions of star systems capable of supporting life, and maybe even countless other universes bubbling away, where is everyone?
Yeah.
Why haven't we found any evidence of other advanced civilizations? Or maybe more creepily, why haven't they found us? The silence is deafening, isn't it?
It is, and this is precisely where the Great Filter hypothesis comes in. It's proposed as a potential and frankly quite chilling answer to the Fermi paradox.
A great filter.
Okay, what's the idea? The core idea is that the path from just a raw star system, planets, stars, basic chemistry, all the way up to an advanced space colonizing civilization, that path involves a whole series of steps. And the hypothesis suggests that something along that path makes at least one of those steps extremely, extremely improbable for life to pass. It acts like a filter that prevents most, if not practically all, potential civilizations from ever reaching the stage where they could communicate across interstellar distances or spread throughout the galaxy.
What kind of steps are we talking about? Is it like the jump from non-life to life?
Oh.
Or from single cells to complex animals?
The source lists a number of potential steps along this evolutionary and technological path. It includes things like having the right kind of stable star system with a habitable planet in the first place. Then the spontaneous emergence of simple reproductive molecules like RNA or something similar. Then the jump to simple single-cell life.
Okay, abiogenesis.
Right. Then the evolution of complex single-cell life, like eukaryotes, which was a huge step on Earth. Then developing sexual reproduction. Then the transition to complex multicellular life.
Animals, plant.
Exactly. Then the evolution of tool-using animals with sufficient intelligence. Then the development of a technological civilization capable of things like radio astronomy or spaceflight, advancing towards interstellar communication or potential colonization, and maybe finally a widespread colonization explosion across the galaxy.
It's a lot of steps. So the implication is, if getting successful through any one of those steps is really, really hard, statistically almost impossible for most potential life-bearing worlds, then that step is the Great Filter.
Exactly right. And here's where it gets really interesting and maybe a bit dark, connecting back to that silence we observe out there.
How so?
The implication is twofold. Possibility one, if the really improbable step the filter is in our past,
Meaning we already passed it.
meaning something like getting life started at all, or the jump to complex cells, or the
Right.
evolution of intelligence. Maybe that was incredibly difficult, statistically speaking, and we just got incredibly, unbelievably lucky to make it through.
So if the filter's behind us,
Then we might genuinely be alone, or at least incredibly rare, in the observable universe. The silence is because almost no one else made it this far.
okay, that's one possibility.
Mm.
We're the lucky ones. Rare survivors. What's the other implication? The bleaker one.
The other possibility, and for many people, the more terrifying one, is that if those early steps, getting life started, evolving complex cells, etc., are actually relatively easy to pass.
Meaning life, maybe even complex life, could be pretty common out there.
Exactly. If that's the case, then the Great Filter is likely still ahead of us.
Uh-oh.
It's some hurdle, some challenge that reliably prevents technological civilizations like ours from reaching that final stage of interstellar communication or colonization.
What kind of hurdle?
Could be anything. A self-inflicted catastrophe seems plausible. Things like nuclear war, catastrophic climate change, runaway artificial intelligence, maybe misuse of biotechnology. Or perhaps it's something inherent to advanced technology itself, or even some aspect of fundamental physics we don't yet understand that inevitably leads to collapse or destruction.
So the silence of the universe, in that view, it isn't because we're alone.
No. In that view, the silence is because every other civilization that reached roughly our level of technological advancement inevitably encountered this future filter
Yeah.
and failed to pass it. They didn't make it through.
So finding even simple microbial life on, say, Mars
Hmm.
or Enceladus,
Hmm.
that would actually be bad news for humanity's long-term future, according to this argument.
According to the specific interpretation of the Great Filter Hypothesis, as laid out in the source material,
Yeah.
it sounds completely counterintuitive, right? Finding life elsewhere should be amazing.
Yeah.
But the argument goes, finding independent instances of even simple life right here in our own solar system would strongly suggest that those early steps getting life started, maybe even evolving basic complexity, are relatively easy and common throughout the universe.
Which means
It significantly increases the statistical likelihood that the real bottleneck, the Great Filter, is some unavoidable hurdle further down the road, further along the evolutionary or technological path. One that advanced civilizations inevitably fail to overcome before they can spread beyond their home system and make themselves known.
wow. That's a truly chilling thought. The silence of the universe isn't because we're unique or special, but because it's a silent graveyard. Because everyone else hit some kind of cosmic wall, maybe self-inflicted, before they could really get going.
It is one possible, and yes, quite sobering, interpretation of the Fermi paradox offered by this hypothesis. The source also makes an interesting point about how we search for extraterrestrial life.
How so?
It notes that continuing to look for biosignatures, signs of life itself, like atmospheric gases that shouldn't be there naturally, versus looking for technosignatures, signs of advanced technology like radio signals, megastructures, industrial pollution.
Right, life versus tech.
That distinction could actually help us refine where the filter might lie. If we eventually find abundant evidence that simple life, or even complex life, is common throughout the galaxy, lots of biosignatures, but we find absolutely no evidence of advanced technology or communication anywhere, no technosignatures, well, that would unfortunately strengthen the argument that the filter is likely still in our future, lying somewhere between the emergence of complex life and the development of a widespread detectable technological civilization.
Okay. Wow. That was quite a journey. We've gone from consciousness spontaneously appearing out of random quantum fuzz
Boltzmann brains?
to potentially living inside a giant computer simulation designed by who knows what,
The simulation hypothesis.
to universes that bounce back and forth in endless cycles, maybe powered by colliding brains or weird ghost fields,
Cyclic and ekpyrotic models.
to maybe invisible shadow matter sharing our very space.
Shadow sectors, mirror matter.
And finally, landing on the possibility that the vast, silent cosmos around us is either profound proof of our improbable uniqueness or a really chilling warning sign of our own likely impending doom.
It's definitely a set of ideas that pushes hard against the boundaries of known physics and philosophy, too. They really challenge our most fundamental perceptions, our perception of reality itself, the nature of existence, where the universe came from, where it's going, and ultimately our place within it all.
Yeah.
They're a potent reminder of how much we still fundamentally don't understand and just how strange the ultimate truth about the cosmos might actually turn out to be.
Well, thank you for joining us on this deep dive into the cool, the weird, and the sometimes, quite frankly, terrifyingly possible.
Absolutely. Keep questioning, keep exploring those strange corners of the cosmos. There's plenty more weirdness out there.
And maybe leave you, our listener, with this final thought to ponder. Building on all these ideas, the simulation, the Boltzmann brain, the great filter. Considering these possibilities that we might be simulated beings, that conscious existence could just spontaneously arise from literally nothing, or that some great filter might lie inevitably in our future, preventing humanity from ever truly reaching the stars, how does that change how you view the reality of your own existence, the reliability of your own memories, and maybe the possibility of a shared long-term future for humanity in this incredible and perhaps deeply simulated cosmos? Something to think about long after this deep dive ends.